introduce myself. My name is EKA DINA. I'm from class A. Will be presenting the result of soon related to the STEM material, namely transmission line structure. Okay. The next is table of contents. Number one, traditional line design practice. Number two, current deterministic design practice. Number three, improved design approach. Okay, the next material, point one, is traditional line design practice. This is the present line design practice views the support structure as an isolate element supporting half one conductors and overhead ground wire. Or the name is OHG on the either side of the structure, and then based on the voltage level of the line, the conductor and the overhead ground wires are configured to provide at least the minimum clearness. And then this configuration is designed to control the separation of number one. This is the energies parts from other energies parts, and then number two, energies parts from the support structure of other objects, local location along the road. And then number three, energy parts of the ground. And the next, overload capacity factor or OCF to cover an uncertain stemming from the number one, like the likelihood of occurrence of the specific load, and then number two, dispersion of structure strain, and then number three, grade of contraction, and then deterioration of strength during service life. And then next, structure function or suspension, tip and angle, and then the last, other line support components or guys, foundations, and etc. Next, the present line design practice normally consists of the following steps. Number one, the owning utility prepares an agenda of loading events consisting of number one, mandatory regulation from the NESC and other codes. Number two, climatic events believed to be representative of the line's specific location. And number three, convenience loading events of interest, the broken conductor, and then the special requirements and expectations. Each of the loading events is multiplied by its own OCF to cover an uncertain list associated with it to product an agenda of final ultimate design load. Number two, rolling span is identified based on the sag or tension requirements for the pre-select conductor. And number three, structure type is select based on past experience or recommendation of potential structure suppliers. And number four, ultimate design loads resulting from the rolling span are applied statically as components in the longitudinal, transverse, and vertical direction, and the structure deterministically designed. And the next number five, using the loads and structure configuration. Front line fractions are calculated and used to accomplish the foundation design. Number six, the rolling span line configuration is adjusted to fit the actual wall profile. Number seven, structure or foundation design are modified to account for variation in actual span length, change in elevation and running angles. And then number six, science most utilities expect the tenant structure to be the weakest link in the line system. Hardware, insulators, and other accessories components are selected to be stronger than the structure. This is the image for development of loading agenda. The this is the event A, the left and the right, event B, the left and the right, and then the next event C or an ESC, and then this is the grounding or loading event or loading is right to design loading. Okay, this is the search for cost effectiveness about conventional. This is the left performance criteria, and then the right line road condition. This is the performance criteria, uh, static loads, and then clearness, two size or select components, and then two final line configuration, and two material costs. So this is the from final line configuration to local practice, and then to erection costs or total install cost. This is the line road condition, topography, and then constraints to the final line configuration. From this, the topography or constraints to accessibility or the rolling span. The rolling span load or size or select components to final and then etc. Okay. That component along the row that has the highest probability of occurrence of failure from a loading event becomes the weak link in the structure design and establishes the reliability level for the total line section. Components are made from different materials that have different response characteristics and that wear, age, and deteriorate at different rates. It is to be expected that the weak link number one will likely be different in the next, the structure types in use. Number one, lattice towers. Number two, frame structure. Number three, cantilever or guide poles and masts. And number four, combination of the above. And next, this is they are available in a wide variety of materials. Is number one, metal, and then number two, concrete, number three, wood, and number four, plastic, number five, composite, and then next, columns, and variation of all of the above, and then bricks. Okay, the factor affecting structure type selection. There are usually many factors that impact on the selection of the structure type for use in an PDL. As an example, steel lattice towers consist of hundreds of individual members that must be worked together, assembled, and erected onto the four previously installed foundations. The lattice tower requires a large amount of labor to accomplish the considerable number of bolt joints, whereas the pole requires the installation of a few nuts applied to the foundation anchor bolts, plus a few to install the portions. And the steel pole requires a large capacity crane with a high reach, which would probably not be needed for the tower. Inspection, assessment, and maintenance, depending on the owning utility, it is likely their in-house practice will influence the selection of the structure type for use in a specific line location. Likewise, there are short-line maintenance activities that are known or believed to be required for particular structure types. And then uh, number two, line two is current deterministic design practice. This is the tandem and light angle suspension tower. Uh, this is weight span, wingspan, line angle, and then load case. And number one, this is NSG heavy, load even, mm, and then number two, one broken, and then others. Okay, next example of loading agenda. This is number one is NSG heavy. This is the number one location in this. And then number two, one broken and then combined with wine and ice. Number two, this is number two. Okay, number two. And then number three, bundle combined with wine and ice heavy wine. Number three, this is number four, wine on bare towel or no conductors. This is number four. Where number four. And then number six. This is not simultaneously vertical load at any conductor support of 17.790. And number seven, not simultaneously. Okay, this is the result of deterministic design. Four shows that different members of the structure as designed were under the control of different loading cases. form this loading agenda. Okay, the next is the reliability level. This is the diagram block from you, and then uh, under is conductors, insulator, structure, foundation, and two components range to line simulation, to loading events, probability of occurrence, and then next is probability of line survival. This is the this result of the deterministic design. This is the controlling climatic loads. Uh, in this controlling climatic load condition, wine no ice no wine, and then ice no wine no ice. In this leg tension cord of conductor arm, tension cord of OAV arm, condition, and this controlling load reference of per years. Then next, in addition to the interesting observation on the relative reliability level of different components within the structural support system, the output of the simulation study also provides the basis for a decision-making process that can be used to determine the effectiveness of management initiatives under the simple laws of statistics. When there are two independent outcomes to an event, the probability of the first outcome is equal to 1 minus the probability of the second. When these outcomes are survival and failure, this annual probability of survival, the same is 1 minus annual probability of failure, or PS same minus 1 minus PS. It is desired to know what the probability of survival is over an extended length of time and years of survived life. Uh, this is the name is I'm sorry, kurung kurung awal kurung PS1, PS2, PS3, and then multiple by PSN, and then the same to PSN. I'm sorry, this is the material of I'm not understand this rumus or formula, so we can next. The superiority level, a comparison of the total risk that would result from the initial failure of components of interest can be accomplished by making a security level check of the line design by Ostertag. When a critical component in the conductor system fails, energy stored within the conductor system is released suddenly and sets up unbalanced transient that can cause failure of critical components at the next structure. Since the structure was designed for broken conductor bundle and broken residuary continents, it appears the line would not be subject to a cascade from a broken bare conductor. But what if the conductor was coated with ice at the time? Okay, the next is number 3. Improve design approach. Okay, the above discussion indicates that technologies are available to assessing the true capability of an OATL uh, that was created using the conventional practice of specifying ultimate static loads and designing a structure that will properly support them. The most promising of this is this improved design criteria of uh, OATLs based on reliability concept by Ostenga. Currently under development by Tiger Study Commit uh, 22 recommendation for overhead lines. The reference report has been circulated internationally for trial use and comment. Okay, the next, this is the sign. Oh, I'm sorry, this is the Indonesian language. This is the main design. We change router, cable, and insulation design, tower, foundation, and the clamp data. This is uh, B1. B1 the we can put uh, tingkat keandalan and others. Okay, we can skip this diagram block because this is the Indonesian language. Okay, maybe uh, that's enough of my presentation. Thank you for your attention, and if there are many mistakes, I apologize because my condition is sick, not sick. Okay, wassalamualaikum warahmatullahi wabarakatuh.